Hi, I just wanted to go over question 4 with you as well since we didn't get to that in Class Connect. And question 4 says, FG is the mid-segment of isosceles triangle ABC. And this is the original picture. And so this is, similar to what the picture is that you'll have. But if you look at FG, that's right there. And it's the mid-segment of isosceles triangle ABC, this triangle right here. And you can see that I have drawn that separately over there, just the triangle part of this picture. So I took triangle ABC and redrew it over here all by itself. It also says that KM is the mid-segment of trapezoid CDEF. So segment KM is the mid-segment of this trapezoid CDEF. And I also drew that out separately over here. Okay? So we are going to take that information and we're going to find these 4 things. We're going to start with BC. So if we scroll up one slide before that question 4, I had these 2 theorems, the triangle mid-segment theorem, trapezoid mid-segment theorem. And if you noticed on the question that we just talked about, we have a triangle part of that question and a trapezoid part of that question. So we're actually going to use these 2 theorems in our process of explaining how to find those 4 missing measures. If you look at the triangle mid-segment theorem, you notice that if you have a mid-segment PQ, it means, what the mid-segment means is that the sides, each side of the triangle gets split into 2 equal pieces. So BQ, QC are the same. Same thing on the left, BP, PA are the same. Okay? So we're going to take that information and use it here to find BC. If you look at segment BC, it's the entire right-hand side of the triangle. Now I know, because the problem told me that FG is the mid-segment of this isosceles triangle, I know some things about this picture. I know that BF is congruent to FC, just because that's what mid-segment means. If GF is a mid-segment, it means that it breaks this right-hand side of the triangle into 2 equal pieces. And then the same thing on the left-hand side, I know that BG and GA are also the same. So if we go over to the original picture and we look and see what we know about that picture, we know that BF is 12 inches and AC is 25 inches. And I've marked that over here. BF is 12 inches, AC is 25 inches. And since we know that BF and FC are the same now because GF was the mid-segment, we can say FC is also going to be 12. Let me write that on here. There we go. 12 inches. And we are looking for BC. Well, BC is just BF and FC put together. So we can say BC equals BF plus FC. And we know BF is 12 and FC is 12. And so that would mean that our answer for part A for BC would be 24 inches. Okay, now we want to find GF. So I'm going to go back to the triangle mid-segment theorem again so you can see how this works. You also know from the triangle mid-segment theorem that PQ, if you look at this example, PQ is the mid-segment, is equal to half of AC. And AC in this picture is just the bottom, the base of the triangle. So let's go back to our picture. We have the base measurement. We know that AC is 25 inches. So the triangle mid-segment theorem says your mid-segment is half of your base. So let me change colors. Color coordinate this. That means that GF is equal to half of AC. We know that AC is 25 inches, so we want to just take half of 25, and that's going to be our length of GF. So half of 25 is 12.5 inches. So we could label GF 12.5. Go back up and grab purple, and label BC is 24. Okay, so on to the trapezoid. Now we're going to want to take a look at the big picture again, or the main picture, and just see if we can, figure some stuff out from there. So if we look at the trapezoid part, and that's why I draw them out separately, especially if you're one of those really visual people and it's kind of tough to look at this picture where the trapezoid and the triangle are mixed together. I really suggest that you draw them out separately. But sometimes you got to go back and look at the main picture to see how the triangle and the trapezoid relate to each other or interact with each other. So if you look at GE, it has one tick mark. GF also has one tick mark. That means that they are the same. So look at GF. We know that, right? That was in the triangle, and we found it. That was actually our answer for part B. So we know that that is 12.5, and so we know that anything that has one tick mark is also going to be 12.5. So we can start labeling our trapezoid. 12.5, 12.5, 12.5. Okay, so that gives us a little bit of information on our trapezoid. The other thing, if you go back and look at the main picture, something that I didn't include here is that from A to C is 25 inches. So we can put that over here. From A to C is 25 inches. Okay, and I guess I'll just keep the same color, 25 inches. Okay, and so that would tell us we could actually find the whole length here, right? From D to C, just by adding those two together. So 37.5 will be the length of DC. And then now that we have some things labeled on our trapezoid, let's take a look at C. We are wanting to find segment CD. Oh, and look, see, I was actually jumping ahead of myself. We already found it. So let's just write out how we found that. CD we found by adding segment DA plus segment AC. So we added 12.5 plus 25, which gave us 37.5 inches. All right, one more to go. KM. Okay, KM, go back up and read. KM, they told us, was the mid-segment of trapezoid CDEF. So if you've been noticing those slides, or this slide when we're going over the triangle mid-segment theorem, there's also a trapezoid mid-segment theorem. So let's take a look at what that says, because we probably want to use it because in the problem it tells us KM is the mid-segment of our trapezoid that we have in our problem. So if we take a look at this trapezoid, it gives us a little equation down here, something that we know about the mid-segment. So XY is the mid-segment of this trapezoid. The equation says if you add the two bases of the trapezoid, RA and TP, and then you take half of that, that's equal to your mid-segment. Okay, so let's go use that. All right, so we could write out here KM, which is our mid-segment. Grab a different color, let's do green, is equal to half of the two bases of the trapezoid added together. And the base would be EF, and the other base would be DC. So we're going to take EF plus DC. Okay, and I'll do that down here since it's getting hard to see what I'm writing there. And we have the information we need. We know that we can find EF, right? Look at EF. We know that EF is 12.5 plus 12.5. So it would be 25. So KM equals this. And then we would add DC to it, and we already found that in part C of this problem. So now all we have to do is calculate that out. So 25 plus 37.5 is going to give us 62.5. So you want to do what's in the parentheses first. And then all you have to do is divide that by 2, or take half of it. So divide that by 2 and you get 31.25. And so that is equal to km, 31.25 inches. And that's question 4.